So far, we have looked at two number systems, binary and decimal. Another common number system used in computer science is hexadecimal, or hex for short. Hexadecimal notation is a numbering system where everything goes up in multiples of 16. However, because our decimal numbering system only goes up from 0 to 9, to get the remaining numbers, we have to use letters A to F. So, in hexadecimal, the number 6 is 6, just like decimal, but the number 14 is E. Why do we use hex? Well, it's a multiple of 2, so it is relatively easy to move between binary and hex, and can store these values in less space, as an 8-digit binary number would take just 2 hex digits. Because hex is good at representing very large binary values, it is used in many areas of computing, like character encoding, memory addressing, RGB color values, and IP version 6 addresses. So, how do we convert a decimal number to a hexadecimal number? To find out the hex value of a decimal number, we follow a similar process to working out the binary. The difference between binary and hex conversions is that now we have to work out how many times the column number will fit into our desired number. We can see how this works by looking at an example. Let's work out the hex value for the decimal number 20. Just like converting to binary, we must ask similar questions and follow a similar process. Will 4096 fit into 20? No, so we don't have any of these, so we put a 0 in the 4096 column. Will 256 fit into 20? No, so we don't have any of these, so we put a 0 in the 256 column. Will 16 fit into 20? Yes. How many times? 1. So we put 1 in the 16 column. Now we have to take 16 away from 20. 20 minus 16 equals 4. Will 1 fit into 4? Yes. How many times? 4. So we put 4 in the 1 column. So the hex value for 20 is 14. And notice we say 14 and not 14. That's a bit confusing, so let's try another example with a larger number. Let's work out the hex value for the decimal number 109. Will 4096 fit into 109? No, so we don't have any of these, so we put a 0 in the 4096 column. Will 256 fit into 109? No, so we don't have any of these, so we put a 0 in the 256 column. Will 16 fit into 109? Yes. How many times? 6. So we put 6 in the 16 column. 6 times 16 is 96. So we have to take 96 away from 109. 109 minus 96 is 13. Will 1 fit into 13? Yes. How many times? 13 of course. But what is the hex code for 13? Using the table we saw at the start of this lesson, we can see that it is D, so we put D into the 1 column. So, the hex value for 109 is 6D. Let's try one last number, a really big one this time. Let's try 5078. Will 4096 fit into 5078? Yes. How many times? 1. So we put 1 in the 4096 column. Now we have to take 4096 away from 5078. 5078 minus 4096 equals 982. Will 256 fit into 982? Yes. How many times? 3. So we have to put 3 in the 256 column. 3 times 256 is 768, so we have to take 768 away from 982. 982 minus 768 is equal to 214. Will 16 fit into 214? Yes. How many times? 13. But what is the hex code for 13? Using the table from earlier this lesson, we can see that it is D. So we put D in the 16 column. 13 times 16 is 208, so we have to take 208 away from 214. 214 minus 208 is 6. Will 1 fit into 6? Yes. How many times? 6, so we put 6 in the 1 column. So, the hex value for 5078 is 13D6. So we can convert from decimal to hexadecimal, but what about the reverse? Well, converting from hexadecimal to decimal is straightforward. All we need is our hex table from the beginning of this lesson. Let's try converting the hex number D9 to decimal. We'll start by writing the number out into our table. We have nothing in the 4096 column and nothing in the 256 column, so we can leave those alone. We have D in the 16 column. We can see from our hex table that D is the hex value for 13, so we need to multiply 13 by 16, which gives us 208. In the ones column, we have 9, which we don't need to do anything to. Now we just need to add these two numbers together. 208 plus 9 equals 217. So the decimal value for D9 is 217. We also need to convert from binary to hexadecimal. In a previous lesson, we learnt that a nibble was 4 bits. The smallest number we can store in 4 bits is 0. The largest number we can store in 4 bits is 15. We've already seen that in hex, each column goes from 0 to 15. Therefore, each column can be represented as a nibble. We can see this by working through an example. Let's take the binary number 100011. What we need to do is turn these 6 bits into 2 4-bit nibbles. This means we'll need to add 2 zeros to the left of this number. Now let's split this into 2 separate nibbles and treat them as 2 separate binary numbers. We can then convert these 2 numbers easily into hexadecimal by adding up the column values that have 1s in them, just like we do in binary to decimal conversion. The first number is equals to 2. The second number is equal to 3. And then we can combine these 2 numbers together to get our result. So the binary number 100011 in hexadecimal is 23. Remember, that's 23, not 23. Let's try another example. Consider the number 11101010. This is already 8 bits, so we can straight away split it into our 2 nibbles. We can now convert these 2 nibbles into their hexadecimal values. The first number is equal to 14, which in hexadecimal is E. The second number is equals to 10, which in hexadecimal is A. And then we can combine these 2 numbers together to get our result. So the binary number 11101010 in hexadecimal is EA. Finally, how do we convert a hexadecimal number into binary? Yet again, we need to understand that each hex column is basically a binary nibble, a number that goes from 0 to 15. Let's say you have a hex number. We'll use 4D. What we need to do is recognize that these are 2 individual nibbles, and so we work out these separately. First we convert the number 4 into binary. Then we convert D, which is the number 13 in decimal, into binary. Then we simply stick them together. There we have it. 4D in binary is 01001011. So, hex notation involves columns that are multiples of 16. Hex is used to make long binary sequences easier to read. Hex is used in many areas of computing, such as IP version 6 addresses and in memory addressing. The numbers 10 to 15 are represented by the letters A to F in hex. To convert between decimal and hex, we need to work out how many times the column number will fit into our number. Converting to and from binary involves treating each column as a nibble.